Factor the polynomial completely and find its zeros. State the multiplicity of each zero. So I could use the rational root theorem, which would be the factors of this divided by the factors of this, which would be 1, factors of 1 over the factors of 1, which means the only zeros, rational roots that could work are plus or minus 1. And then I could try 1 first, and I would write this as 0, 1, 0, 0, 0, negative 1, mainly because I can rewrite this as x to the 4th plus 0x cubed plus 0x squared plus 0x plus 1 minus 1. But there's actually an easier way to do this than doing all that. This is a difference of squares. So I can actually rewrite this as x squared squared minus 1 squared. Use the difference of squares. That's going to be x squared plus 1 and x squared minus 1. Now if you look right here, that's also a difference of squares. But this one is not. So we'll deal with him later. So we end up getting x squared plus 1. And then x squared minus 1 becomes x plus 1 and x minus 1. Now this is still q of x. Now, in order to fully factor, what that means is everything, all my factors need to be linear. This one's linear. This one's linear. This one's not linear because it has a squared. Now, in order to factor that, if you remember, once you actually have a linear factor, so like x minus a is one of my zeros. So if I can find the zeros of this term right here, I can linearly factorize it. So if I say x squared plus 1 equals 0, and I solve for that, I get x squared equals negative 1. So x equals, so if I square root, plus or minus, we get plus or minus the square root of negative 1, which is I. So my zeros are plus or minus I, and if I stick it back into this formula, so I'm going to rewrite this as I and negative I. So I end up getting q of x equals, now this right here becomes these with my zeros. So you end up getting x minus my first zero, which is I, and then you get an x minus a negative I, and then you get x plus 1 and x minus 1. This right here can reduce to become, so q of x fully factors out to be x minus I, x plus I, and then x plus 1 and x minus 1. Now, that's fully factored. Now, to find my zeros, all I got to do is ask myself, okay, what makes that 0? What makes that 0? What makes that 0? What makes that 0? What makes that 0 is I, but we already found one of the zeros, so we already knew that one. So my zeros are I, and it happens once, so it's going to have a multiplicity of 1. That's what I'm going to do, and that's what the book does to show you it's a multiplicity of 1. I have negative I, which has a multiplicity of 1. It only happens once. I have negative 1, which only happens once, and then I have 1, which only happens once. So I have 1, 2, 3, 4 roots, which, that's what we knew because this is a degree 4 polynomial, which means it's going to have 4 zeros. And my linear factorization will have 4 terms.